Welcome to episode 12 of my calculus series. Today, we're diving into indefinite integrals. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. What is an indefinite integral? If the derivative of capital F of x is little f of x, then the indefinite integral of f of x with respect to x is f of x plus capital C. This process is called antidifferentiation. Notation. Here's how we read the notation for integrals. The symbol that looks like a stretched S is the integral sign. Next comes the integrand, which is the function we're integrating. The dx tells us the variable of integration. And finally, the constant capital C is the constant of integration, because integration gives a whole family of functions. Basic integration rules. Some rules to remember. The integral of x to the power n, with respect to x, is x to the power n plus 1 over n plus 1, plus c. This only works when n is not equal to -1. The integral of 1 over x is natural log of the absolute value of x, plus c. The integral of e to the x is just e to the x plus c. The integral of cosine x is sine x plus c, and the integral of sine x is negative cosine x plus c. Let's try an example. Evaluate the integral of open parenthesis 3x squared minus 4x plus 5, close parenthesis dx. Solution. We integrate each term. 3x squared becomes x cubed, negative 4x becomes negative 2x squared, and 5 becomes 5x. Don't forget to add c. Final answer. X cubed minus 2x squared plus 5x plus c. Next example. Evaluate the integral of square root of x, dx. Solution. Rewrite it as x to the 1/2. Then increase the exponent by 1, you get 3/2, and divide by that new exponent. So the answer is 2/3 x to the 3/2, plus c. Exponential and logarithmic functions. Example. Evaluate the integral of e to the 2x. Solution. We divide by the coefficient of x, so we get 1/2 e to the 2x, plus c. Another one. Integral of 1 over x, dx. This is the standard result. Natural log of absolute x, plus c. Example. Evaluate the integral of sine of x. Answer. Negative cosine x, plus c. Next. Evaluate the integral of secant squared x. Answer. Tangent x, plus c. More trigonometric functions. Example. Evaluate the integral of secant x times tangent x. This is a standard result. Secant x, plus c. Inverse trigonometric functions. Example. Evaluate the integral of 1 over square root of 1 minus x squared. This is the derivative of arcsine. So, the answer is sine inverse of x, plus c. Next example. Evaluate the integral of 1 over 1 plus x squared. This is the derivative of arctangent. Answer. Tangent inverse of x, plus c. Using substitution. Example. Evaluate the integral of x times cosine of x squared. Let u equal x squared, then du is 2x dx, which means 1/2 du equals x dx. Now the integral becomes 1/2 integral of cosine u. The antiderivative of cosine is sine. So, the answer is 1/2 sine of x squared, plus c. Next example. Evaluate the integral of 2x over x squared plus 1. Let u equal x squared plus 1. Then du equals 2x dx. So the integral becomes the integral of 1 over u, which is natural log of absolute value of u, plus c. Final answer. Natural log of x squared plus 1, plus c. Summary. Let's recap what we learned. Indefinite integrals reverse derivatives. Always include the constant of integration, c. The result is a family of functions. And finally, we can compute integrals using basic rules and substitution when needed. That wraps up episode 12 on indefinite integrals. Now that you've got the rules and techniques down, try practicing them on your own. And remember, if you found this lesson helpful, please like, follow on TikTok, or subscribe on YouTube so I can keep making more videos like this. Thanks for watching, and I'll see you in the next episode.